Hello everyone, myself Bharadwaj. In the previous videos, we discussed about cyclic communication for data exchange between field devices and control system. In this video, I will explain another concept. We use heart communicator to configure our field instruments. We can configure the range, we can do the calibration, we can view the diagnostic messages, alarms, alerts, etc. on the heart communicator. Now I will take that example. Let's say I have a heart communicator and I want to connect this heart communicator to this pressure transmitter, and I want to know the configured range in this pressure transmitter. Now let us see how this system works in Foundation Fieldbus. I connected the heart communicator on the communication network, or we can connect the heart communicator directly to the pressure transmitter. Remember, as this is a Fieldbus communication, we can connect this heart communicator anywhere in the loop. So when you connect this heart communicator to this communication network, you can able to view all the available devices on this communication bus. That means when you connect your heart communicator to this pressure transmitter, you can also view the all the devices connected to this junction box. That means whenever you connect your heart communicator, you are able to see the live list. This is the live list prepared by the LAS, link add to scheduler. Now let us see how this operates on this communication bus. Whenever heart communicator needs some data from any instrument in the junction box or the devices connected to the communication bus, then the heart communicator must request permission from the LAS, link add to scheduler. So first the heart communicator must request permission from the LAS. So it will send one request that I need to communicate with some instrument, I need some data. Let's say in this case, I need to view the pressure transmitter configured range. Then first it will ask the permission from the link add to scheduler. Once the link add to scheduler receives the request from the heart communicator, next it allocates the available time slot to this heart communicator. Then it will give the permission to the heart communicator. Let's say the link add to scheduler assign some time slot to the heart communicator. Then it will update the heart communicator that you have the permission now, so that you can speak or you can discuss with your required device. That command name is pass token. The LAS will send the pass token to the heart communicator. This is nothing but you have the permission and you have the time slot assigned for you. You can discuss with your pressure transmitter, you can discuss with your field instrument in this time slot. Then the heart communicator requests the data from the pressure transmitter. Either it can read the data from the pressure transmitter in this time slot, or it can write the data to the pressure transmitter. You can do any task. Let's say I want to view the pressure transmitter configured range. In this case, the heart communicator is called as client. The client is requesting the data. Any instrument or device which requests the data, or it may write the data, or it may read the data as per the requirement, that device is called as client. So it will send the request that you need to send me the range. So it is heart communicator sends the request or asking the pressure transmitter that you have to send me the present configured range. Once this instrument receives this instruction from the heart communicator, this instrument will send the data, requested data, to the heart communicator. It is sending the range. My present configured range is 0 to 10 bar. In this case, this instrument which sends the data is called as server. The client requests the data and the server responds. Server updates the data. That is why this model is called as client server model. So with using this client server model, the hot communicator, the client can request the data, or it may read the data, or it may write the data. For example, you want to change the pressure transmitter range from 0 to 20 bar. In that case also, it will use as client server model. Either you want to read the data or you want to write the data in any instrument parameter, any instrument configuration settings, then in FF communication, it uses client server model. This client server model will be applied to diagnostics, calibration, configuration, alarms, maintenance alerts, etc. Now, let's say the hot communicator job is completed. Then it has to update the link add to scheduler that my job is completed. For that purpose, as it is already having the pass token with this hot communicator, it received from the LAS. Now it will send the pass token again back to the LAS that my job is completed. You please update accordingly. So this hot communicator will send the pass token back to the LAS after completing the job. Then the link add to scheduler updates its status and updates the time slots as per the requirement. So the hot communicator no longer has the pass token because it given back to the LAS. So this is complete cycle. When you are working in the industry, you know that we will do the configurations of the instruments, calibration of the instruments when we have a requirement or when we have a scheduled maintenance, right? There is no need to perform these tasks every day or every cycle. If you compare the previous cyclic communication or publisher subscriber model, the foundation field bus must execute that cyclic communication for every cycle such that it has to update the measured process parameters to the control system. But if you compare to this client server model, this client server model is only required when we have some requirement, when we need some information, or when we want to do the calibration of a field instrument. That is why this is called as acyclic communication. So it is clear that in foundation field bus, mainly we have two types of communications. The first one is cyclic communication and the second one is acyclic communication.